Hey guys, so looking at your homework for today, number 13, the very last one, is really difficult. So I wanted to do a video working through this one with you so that way you understood. And I'll give you another problem similar to this on Monday. So let's take a look at this one and see what it is that we do. So the directions say write the following as a single fraction. Okay, so as a single fraction in its simplest form. So here we are adding and subtracting fractions. Now, if you remember, I cannot take these two terms and cancel them out because both terms are married, right? They both have good positive relationships. So this x is not going to go away with this x. This x has a partner. This x has a partner. So they're not going anywhere. Same thing over here. I can't cancel out this x with this one because this x has a partner. It's not going anywhere without it. So what we have to do when we are adding and subtracting fractions, we have to have the same denominator. So what I'm going to do to make it the same denominator, if you remember also, so the name of the top is the numerator, the name of the bottom is denominator. So what I need to do with that is I'm going to multiply this first fraction by the denominator of the other fraction on top and bottom. The reason I do top and bottom is because it's the same as multiplying it by 1 because they would cancel out if I were to simplify. And so same over here. I'm going to multiply top and bottom by the denominator from the other fraction. Now I want to multiply. So I'm going to leave the bottom. Actually, whatever. I'm going to go ahead and I'm going to FOIL that now. So when I'm multiplying over here to the side, let's say I'm going to do it in a different color. So I'm going to multiply this over here. So we've got x plus 1 times x plus 5. X times x gives me x squared. X times 5 gives me a positive 5x. 1 times x gives me just x, and 1 times 5 gives me 5. Now I combine my like terms, and it gives me x squared plus 6x plus 5. Okay, so I'm going to write that here. And that is the denominator for my first fraction, but it's actually going to be the denominator for my second fraction also because they're exactly the same. Now let's take a look at this over here. So I've got x plus 1, and I'm multiplying it by x plus 1, same deal. X times x gives me x squared. X plus 1 equals x. X plus 1 equals x. And 1 times 1 equals 1. Now I combine my like terms. X squared plus 2x plus 1. So I'm going to put that here. And lastly, I'm going to multiply these together over here. So x times x plus 5, a little simpler. X times x equals x squared. X times 5 equals 5x. Now, because my denominators match, because they are the same, I can now combine my numerators. So I'm going to rewrite my denominator once. And I'm going to combine my numerators. However, you must be very careful because I have a negative here. And what that means is I need to distribute that negative to both parts of the numerator for my second fraction. So this isn't going to be minus x squared plus 5x, but it's going to be minus x squared minus 5x, because that negative times a positive gives me a negative. Now I can combine my like terms in my numerator. Here I have x squared minus x squared. Those two cancel one another out. Then we have positive 2x minus 5x. That's going to give me a negative 3x. And then I have just a plus 1 and then nothing else to add it to. So I'm going to put that 1 out in front here. And then we put that over our denominator again. And when I'm looking, these two share an x and a 3 in common. Can I simplify? Can I divide both of those by 3x? No, you cannot, because this 3x is married to this 1, just like this 6x is all part of this family down here. So you can't split anything up. If I can take out a GCF from this top and simplifying it with a GCF from the bottom, then I can simplify further. But I actually can't do that. There isn't a GCF for the top or the bottom. So this is my answer in its simplest form. So this is my answer. Okay?